Good morning, everybody. I have to keep my voice down a little bit. I don't want to be too loud. People are still sleeping in the house. So I want to start us off and congratulate us all by getting through Chapter 6, because now we're on to our last chapter in Chapter 7. And we're going to start Chapter 7 with Section 7.1, which is titled Completing the Square. Another way of solving these quadratic equations and their functions. Okay, so we're not doing all the sections. We're going to be skipping 2 of them, I believe. So I'll look in your syllabus and you can find that out. But I know we're doing 7.1, so let's get started with that. And we're going to start talking about the square root method, or the square root property. And a quick example of that to refresh us would be something along the line of x squared that equals 16. All right, using the square root property to get the x's separated, so I just have this solved for 1x, I would take the square root of both sides. Okay, if I take the square root of both sides, then x is going to equal 4. But I have to remember to put a plus or minus in front of my answer, plus or minus, because 4 could be -4 or +4. Okay, so I want us to know that the square root can be, the answer can be -4, because it's an even exponent too, just to add that flavor to it. All right, but our notation has to have the plus or minus before the answer of that portion of the problem. Okay, so given that, let's go on to our example. And I'm going to do the examples now, not the practice problems, because I get so confused. All right, so I'm going to have 2x minus 3 squared, and that's going to equal 25. Let's do our first example here. So that's example 1. All right, I've got this binomial squared, so I'm going to take the square root of both sides. My left side is just going to be 2x minus 3. And that's going to equal, square root of 25 is 5, but I want to put it as plus or minus 5. Okay, now I'll proceed to solve for x. Okay, if I do that, I'm going to add 3 to both sides, but I'm not going to add it to the 5 yet. I'm going to add it to, I'm just going to put it in front. So it says 3 plus or minus. I'll show you that right now. So it's going to be 2x equals 3 plus or minus 5. Okay, and then I'll take that and divide both sides by 2 now. So x. Where did I go? X equals 3 plus 5 divided by 2, or 3 minus 5 divided by 2. And I'll take the separation now and solve for x, and so accomplishing the fact that I'm going to be using the plus or the minus, and I'll figure those out separately. So x is going to equal 3 plus 5 is 8. 8 divided by 2 is 4. Or 3 minus 5 is -2. -2 divided by 2 is -1. And then these are my solutions for that first example. Okay, winner. And again, you can always plug back for x, these values, to figure out your answers. Sometimes they get a little complicated, and I'll do one example of testing our answer if it's correct. Probably I'll do it on example 2. And here's example 2. So I'm going to have 3x minus 1. That's squared, and it equals negative 12. Oh, I got a negative 12 now. Okay, let's see now. Because of the learning we did of imaginary numbers, now when I take the square root of a negative number, I've got an answer, and it involves the I, the number I. So let's go. I'm going to square root both sides because this is a binomial squared. So I'm going to have 3x minus 1. That's the square root of 3x minus 1 squared. And that's going to equal, let's see, I've got the negative 1, so I'm going to have an I out front. And then I'm going to have a, let's see, 12. Square root of 12 is 4 times 3. And the square root of 4 is 2, so 2 comes out. Let me scoot that over a little bit. So 2 comes out in the I, and what's left inside is the 3. And in front of that, I've got my plus or minus whenever I'm taking the square root of that number. All right, let's proceed. I'm going to add 1 to both sides. The 1 I'm just going to put here. And I've got 3x equals 1 plus or minus 2I root 3. And finally, divide both sides by 3. So, x equals 1 plus or minus 2I root 3 divided by 3. Okay, and I said I would check this answer out. All right, let's check the answer out. There's my answer, that x equals, remember it's 2 answers too, by the way. Original problem was 3x minus 1 squared and equal to negative 12. All right, so x equals this thing here. All right, so I'm going to carefully write that up. I'm going to have 3 times x, and x is 1 plus or minus 2I root 3, all divided by 3. Oh, I got this minus 1. That's going to be, minus 1 is like so. That's all divided by 3. So let me write that up correctly. So it'll be looking like this. And this is this way, I suppose. Okay, and it's squared. Equal to negative 12. Let me see if I got that right. 3 times x, and that's this. 3 times x, 3 times x minus 1 squared equals negative 12. Okay, that's fine. And so let's simplify that now a little bit. The 3's cancel out. And then also I've got 1 minus 1. So those are gone. So all I have left here is 2I root 3 squared. That equals negative 12. Okay. When I simplify this, I'm going to have 2 squared, 2I squared. I'm going to have that whole thing squared, right? So I'm going to have, what am I going to have? 4I squared times 3. Because the square root of 3 is square root of 3 squared is 3. Okay, and that's going to equal negative 12. Well, I squared is the negative 1. So that's going to be negative 1, 4 times negative 1 times 3. equals negative 12. So negative 4 times 3 is negative 12. And negative 12 equals negative 12. So my solution is correct. It's a little tricky figuring that out, but we did it. You can go over that a couple times if you like. Okay, let's go on to example 3. Let's see what that's about. Okay, so here's our next problem, and this problem is designed for us to recognize that this x squared plus 6x plus 9 is a perfect square trinomial. But in all honesty, many people don't recognize that. When I was doing this, or learning this anyway, I looked at this as a quadratic equation, and what I got to do is get it equal to 0. So I would bring the 12 over to the left side. And let's say if I subtract 12 on both sides, then I've got x squared plus 6x minus 3 that equals 0. And then looking at this, well, what are you going to do with this? So that didn't work for me. Okay, granted. But now what they expect us to do is to recognize that trinomial. Is it a perfect square trinomial, first of all? And if it is, we're in luck. All right, so here's what they want us to do. So what's needed here is for us to recognize x squared plus 6x plus 9 can factor and equal 12 this way. I have x plus 3, and then I can write it up as x plus 3 squared equals 12. That's more in tune of what we're learning in chapter 7 now, using the square root property. Okay, so given that, I'm going to take the square root, both sides, and that's going to give me what? X plus 3, and that's going to equal 2 plus or minus 2 root 3. And then how about we subtract 3, both sides, and I'm going to have x equals negative 3 plus or minus 2 root 3. And that's it. Check that. Now you can take that answer and plug it in and see how you do with that. That is going to be my final answer for that example, which is example 3. Okay, here is our next section of objective B, I should say, where we're going to learn how to complete the square, dealing with trinomials. First of all, x squared plus 8x plus 16. These are perfect square trinomials. These, because I'm going to write down a couple more. X squared, how about minus 10x plus 25. Okay, and one more maybe. This got plenty of room. X squared minus 12x plus 36 equals. All examples of perfect square trinomials. I'll make this a positive 12. Doesn't matter. So this first one here I could also write as x plus 4 squared. I want to be able to do that so I can take the square root of that, since we're completing the square or doing the square root method. This one I could write as x minus 5 squared. And here's a third one. There's many, many more. I just want to give you an idea what we're looking for, what we're trying to achieve. And this third one would be x plus 6 squared. Okay. So this is just a brief idea of what we're looking for in our quadratic equations, what we're trying to figure out, find, I should say. All right, so here's another example of where I'm going with this. Now, this is a problem that we can solve by not completing the square, just in traditional ways. So if I have x squared minus 6x plus 5, then I could factor this with two binomials, equals 0, of course. Okay, what would I have? So I got an x here and an x here, a minus and a minus, and my two numbers are going to be 5 and 1. Okay, and that'll give us our solutions that we need of x will equal 5 or x can equal 1. Okay, so we can agree to that. That's fine. But if I'm doing the method of completing the square, I'm going to take that same problem, x squared minus 6x plus 5, that equals 0. All right, so when we complete the square, what I want to do is I want to make sure my lead coefficient is 1. So if this were a 2 or a 3, whatever number that would be, I'd have to divide it by whatever number is there. So if this is n, I'll say any number, nx squared, then I have to divide everything by n, even the 0. Okay, that makes the n's cancel out, and I've got 1x squared. And whatever I'm ending up with over here, that's fine too. All right, but it's not the case here. We're just learning this, so they're giving us a little break. So as long as this is 1, then I can proceed. And what I want to do is I want to subtract 5 from both sides. And that's going to give me x squared minus 6x plus what? Equals negative 5. And now I have to proceed to write up what number am I going to put here in that box. I cleared it out by subtracting the 5, the c value, written in the standard form. So I'm going to come over here and I'm going to do a little side work. I'm going to take b, divide it by 2, and square it. That's what I'm going to do when I'm doing these problems. So I'm going to take negative 6, divide it by 2, and then square it. Okay, so that's going to give me negative 3 squared is 9. So I'm going to write up a 9 here, and then I'm going to write up a 9 over here. Add 9 to both sides, in other words. Okay, so what have I got? I've got x squared minus 6x plus 9 equals 4. Okay, I can change that too to 4. Okay, so now I want to write this quadratic expression as x minus 3 squared. That's the reason for creating the perfect square trinomial. That's what we're doing. So I can rewrite it this way, in this form. And that's going to equal 4. Okay, proceeding, x minus 3 squared equals 4. I'm going to take the square root of both sides now. Let me get a different color. Square root of both sides. And I'm going to have x minus 3 equals the square root of 4 is plus or minus 2. And get the x by itself, I'm going to add 3. So x equals 3 plus or minus 2. Okay, so therefore I'm going to figure out each of my answers for x. So x is going to equal 3 plus 2, which is 5, or x is going to equal 3 minus 2, which is 1. And these are the same answers we had when we just did it the traditional way up here. X minus 5, x minus 1 equals 0. If I would have finished that, you would have seen that x would equal 5 or x would equal 1. But that's what we do when we're completing the square. We clear out C, the C area, and then fill it in by, well, I'm going to show you instead of just me telling you. Okay, so that was example 4. We completed the square. How about we do example 5 now? Okay, and they want us to do this by completing the square again. All right, so what's the criteria? My lead coefficient has to be 1, so it is, so we're good with that. And then I want to get rid of the C value that is currently there. So I'm going to just simply move it over to the right side by adding 2 to both sides. Okay, then I've got x squared, move this up, x squared plus 5x plus what equals 2. And now I want to create the perfect square trinomial on this left side. And how do we do that? We do that by taking 5, the b value, which is 5, divide it by 2, and then square it. Okay, take the b value, divide it by 2, square it. And this ends up becoming 25 over 4. Ooh, 25 over 4. And I'm adding 25 over 4 to both sides. Okay. And going forward here a little bit more, I'm going to write this up as that binomial squared. So let's see, what is that going to be? That's going to be like so. This is a little more daunting than really what it is. It's going to be, I'm going to have an x here, plus and plus. And my number that's going to go here and here is going to be what's inside the parentheses here. That 5 over 2. 5 over 2. 5 over 2. Okay, that's where it's located, so we don't have to think that much about it. And just do a quick check and say, what's 5 halves times 5 halves? Well, it's 25 over 4, which is right here. Remember, that's our C value. That's last in the FOIL method. And that's what we're multiplying, the last terms of the binomials. Okay, and then that's going to equal 2, and 2 plus 25 over 4 is 2 and 25 over 4. But I want that not in a mixed number, I want it as an improper fraction. So that's the same as saying 2 times 4 is 8, 8 plus 25 is 33 over 4. And we're in great shape now. I'm not crazy about the 33, but hey, we know how to handle that. Okay, so take a good look at that. And now, for your sake, you don't have to literally write that up as x, but that's what this means. This is x plus 5 over 2 squared. That equals 33 over 4. So you can write it up this way, but you don't have to. You can just take the square root of this whole thing. There's 2 of them. For every 2, you take 1 out. Bingo. So that's just a little minor shortcut you can take. Because now from here, I'm going to take this, the square root. The square root, and then on the fraction, when I have a fraction over here, I'm going to do that separately. Square root of 33, square root of 4. And this, of course, is the plus and minus. So I'm going to throw that in there as well. All right, so what have I got? The left side is just going to be x plus 5 over 2. And that's going to equal plus or minus the square root of 33. over the square root of 4, which is 2. And now it looks like I have one more step, and that is to subtract 5/2 to both sides. Subtract 5 over 2 and subtract 5 over 2. And my final answer is going to be x equals -5 over 2 plus or minus root 33 over 2. And that's a satisfactory way of writing it. You will have to check on your homework. Maybe do, when you're doing your homework problems, I don't recall how you, I think they want them separated, your answers. And you can find that out by the way it's displayed on your page, or you can do an example problem and look at how they have the answer written. Okay, so that was example 5, and we're done with that. Okay, let's go on. Example 6. All right, example 6, here we are. A little bit different now. I've got 3x squared. That 3 cannot be there. I have to get rid of the 3 and make it a 1, so I'm going to divide every term in the problem by 3. Even the 0. All right, so when I do that, I'm going to have, what am I going to have? X squared minus 8 over 3x plus 7 over 3. That's going to equal 0. Okay, what did I do there? I accomplished getting the lead term, the lead term's coefficient to be 1, so I divided everything by the lead coefficient, which is 3. All right, so now what I want to do is I want to clear C out of the way, so I'm going to subtract 7/3, both sides, and I'm going to have x squared minus 8 over 3 x plus what is going to equal -7 over 3. Okay, my big task here is to complete the square on the left side. Okay, the way I go about doing that is take b, which is -8 over 3, divided by 2, and then square it. Okay, so let's see. How about we have -8 over 3 divided by 2, so what I end up doing is multiplying the 3 times the 2, and that'll give me -8. Hold on one second, let me rearrange my board here. Okay, here's where we're at now. I took the -8/3, divided it by 2, and now I'm going to square it. Okay, so my point here was -8 over 3 divided by 2 is going to be -8 over 6. And then I'm going to square that. I'm going to simplify -8 over 6 by writing it up as, what is that? 2 goes into both, so I'm going to have -4 over 3 and square that. And now I'm in business because that's going to give me 16 over 9. Now we'll put 16 over 9 here, and 16 plus 16 over 9 here. Plus 16 over 9. Okay, I think I've got that, doing okay with that so far. All right, so I'm going to add those two up together, and here on the left side I'm going to have my perfect square trinomial. So I need this to help me figure it out. So I'm going to have x minus something and x minus another something. So what numbers go here and here? It's going to be this 4 over 3 minus 4 over 3 minus 4 over 3. Whatever is there. I'm using the minus sign along with the subtraction sign. So be careful of that you don't turn it into positive. And now that's going to equal, I've got to add up these two. This is 16 over 9. Let me try it here for a moment anyway. 16 over 9 minus 7 over 3. Okay, I'll make my denominators 9 by multiplying the 7/3 by 3 over 3. So that'll be 21. 16 minus 21 is negative 5 over 9. And that's what this is going to equal over here, which is negative 5 over 9. Let me do some erasing again. Okay, remember that number, negative 5 over 9. Okay, so I've got negative 5 over 9. All right, take the square root of both sides now. Square root, negative 5, square root of 9. All right, so what have I got? X minus 4 over 3 is going to, because I'm taking the square root of this, so it's x minus 4 over 3, and that's going to equal plus or minus the square root of negative 5. Well, I've got I comes out, I got an imaginary number, a square root of 5, over the square root of 9, which is 3. Okay, take a good look at that. And now all I have to do is get x by itself by adding 4/3 to both sides. If I do that, then x is going to equal 4 over 3 plus or minus I root 5 over 3. Okay, and again, you could write this up as x equals 4 plus or minus I root 5 all over 3. You could write it up this way or this way. I think the book wants you to separate them though, which is neither way that I've got it written up there. Okay, I ended up with the correct answer. And again, this is the process of what we're doing this. Let's do number 7. What's that about? Okay, another one. Let's see, it says find the x-intercepts of the function f of x equals x squared plus 6x plus 7. Okay, so when we're finding the x-intercepts, we have to do what? We have to let y equal 0. All right, and we remember that f of x is the same as y. All right, so this would be if f of x is y, and then we're going to let y equal 0. So I have that function that x squared plus 6x plus 7 equals 0. I'm just bringing the 0 from the left side and bringing it over to the right side. So it equals 0, and then I can scratch that away. Okay, and I've got to factor this. Boy, it sure looks like I can factor it, but I can't quite factor it, right? We'll all be trying to do something like that. So if I were to try it, just real quick, I'm going to have x plus, and then I think I'm going to go 7 and 1, or 6 and 1. But 6 times 1 is 6, not 7. I need 7. So you go back and change that to 7. You got 7 times 1 is 7, but 7 plus 1 is 8, not 6. So you can see I can't factor in the traditional sense. So I have to do it by completing the square. Okay, so let's go ahead and do it. My lead coefficient is 1. That's good. I'm going to clear out the c here, and by subtracting 7 on both sides. So now I've got x squared plus 6x plus what is going to equal -7. Okay, so let me figure out what number goes here. I'm going to take the 6, which is b in standard form, divide it by 2, and then square the whole thing. So 6 divided by 2 is 3, and 3 squared is 9. So we did this one before earlier. So I got 9 here, and I'm going to add 9 here. 9 to both sides. Okay, my left side, I can factor that now. It's a perfect square trinomial, and that's going to be written as this. So if you're going to factor that, I'm going to continue to do it this way. -7 plus 9 is 2, so that's easy. Over here, I'm just going to factor it as it's given. It's a perfect square trinomial. That's why we're doing this. So if a perfect square trinomial, they're easy to factor. So I'm just going to write it up this way. And there's 2 of them there that I've got. So I'm going to take the square root of the whole thing, which I was trying to explain to you earlier. And when I take the square root on the left side, I take the square root on the right side. And don't forget, that's plus and minus the square root of 2. So the left side is going to end up being x plus 3. The square root of x plus 3 times x plus 3 is x plus 3. And that's going to equal plus or minus square root of 2. And now all I have to do is subtract 3. Subtract 3. So x is going to equal -3 plus or minus root 2. And that looks like a bingo. Done. All right, I've got on page 587, page 587 of our textbook, there are the rules written out for solving a quadratic equation by completing the square. And, you know, you may want to copy that or take a picture of it and have it with you, so you're not lugging around the book for yourself. All right. And hold on one moment, please. Well, ladies and gentlemen, I just checked, and we do not have to do Objective C of Section 7.1, so we are done with 7.1. All right. I hope you find this doable, comforting. I'd say you got any questions, ask, but you all seem to be doing pretty well this semester, and I'm very happy for you. All right, so let's go and end this session, and we will move on to 7.2 next. That's it. Talk to you later.